It is my distinct pleasure to introduce our keynote speaker today, Weisong Shi. Dr. Shi is an alumni distinguished professor and chair in the Department of Computer and Information Science and the Department of Mechanical Engineering at the University of Delaware. Before joining the University of Delaware, he was a professor at Wayne State University from 2002 to 2022, where he also served as Associate Dean for Research and Graduate Studies in the College of Engineering. He currently serves as an honorary director at the NSF ECAT, Industry University Cooperative Research Center, dedicated to advancing electric, connected, and autonomous mobility technologies. He is an internationally recognized leader in edge computing, autonomous driving, and connected health. His paper, Edge Computing, Vision and Challenges, received over 8,000 citations. He is an IEEE Fellow, an ACM Distinguished Scientist, and the founding father of this conference. Dr. Shi, it is my distinct pleasure to welcome you to give this keynote address.
Thank you so much for the nice introduction. Okay, let me, okay, works. Good morning, everyone. I know it's very difficult to getting you into the sitting in a conference room in New York City, right? There are so many, there are so much fun outside here. First, I would like to thank you for your coming here. For this talk, that when Hong Kong invited me to give a keynote here, I was, are you sure? You know, as Antonina just mentioned that I started this conference about 10 years ago. But then I realized since this year is the 10th anniversary, so maybe I can take this opportunity to share with you a little bit about the background of this conference and the journey. And in particular, I want to inspire some of the young, colleagues. If you have something in your mind, I know a couple of colleagues sitting there, they also dream big. So if you think about, launch something, so maybe some of this experience can inspire you to do this. Maybe by 2035, some of you are going to be like me standing here for some of your own conferences. So that's just a little bit of background here. For this talk, I try to make it really easy, for you to understand it. So you can sit here, relax, and then sort of listen to some kind of a story. It's different from the two keynotes from previous days. I know Xihong, we invited from Harvard, so she's coming very specific on the research. And then Wendy Nielsen is talking about, from the NSF point of view. So this is a kind of, not really tech depth, on that. But I want to share with you some personal journey here. So I call it 15 years Odyssey in the connected health. Basically, it's trying to reflecting what's going on in the connected health, and then what is, in my view, what's the future that one of the potential future directions. Obviously, you can have more things you might have in your mind. So here is a brief outline. Here is I want to share with you back to 15 years ago. I know for some of you probably at a similar academic age, so you know that 15 years, what does that mean? But for many of you, 15 years ago, sitting here, you probably are still middle school students, I guess, right? So some of you probably just at that stage. So that I want to share with you some of the slides was really old, relatively old. It's not that old, but it's, and then I want to share with you some lessons and challenges I observed, not just in my own research, but also through observed this, I come to this conference every year. So I watch some of you become students, studying a poster, and then now become a professor. I met a couple of you just now. So lessons and challenges. And then I want to share with you some of the new opportunities. Obviously I'm not a, AI person, so we're not talking about AI-enabled things. You already heard tons of this topic. So it's a totally different angle. What's the future for for the connected health. So now let's take a look at this figure. I was used about 15 years ago when I make a case at the Wayne State University. As Antonina just mentioned, I spent 20 years at the Wayne State before I joined the University of Delaware. So here is a figure shows that basically we're choosing the too big. Again, this is about 15 years ago. The figure here shows that how much the GDP you're spending on the health. In the United States, it's right now is here. But I saw when these slides yesterday was like you studying is a downgrade. But anyway, this gives you a picture. The health is a big expenditure, right? So that's the first thing. But then think about 2010, okay? Just I don't know, encourage you to close the eyes, but think about 2010 at that time. So there is two technologies was really is booming. So the one is wireless technology. It's almost getting everywhere. So this figure shows that the different countries, the number of mobile phones. And then this is another, the picture shows the different countries, how this wireless technology has been penetrated. You are not supposed to read each of this. Just give you a feeling about, for example, South Korea was the highest penetration is 97. And those are all those countries actually is leading in the connected health. It's because you need to connect it. Number one is if you are not connected, like at that time in Detroit, 40% of the population don't even have a phone. So when we're starting a project, people said, what are you going to do with these people? You have to make a phone call to them. But then they said, I don't even have a phone at home. So now what do you do? So that was 2010 in city of Detroit. 40% of the population don't even have a phone. So this was like a kind of a very interesting observation at that time. But the wireless technology is moving forward. And then you can see that today Wi-Fi speed is much faster. But this roughly gives you an idea about it. There's no 5G at that time either. Okay, that was. And then we talk about this is a great opportunity. Because the wireless technology is there, then we can start in connected health 1.0. So basically, as you can see here is we're showing some of the things. But if you think about 15 years today, does all this vision implemented? Probably not. So here is the idea that just to give you a picture here. Today, if you go to a hospital, you probably still see a lot of this wires putting EKG sensors on you. So we call the connected health 1.0. So basically, the goal is one, replacing those wire with wireless. That was in the conventional health domains. So that was the first motivation. The other one is trying to new potentially paradigm shifting health solutions. So that was at that time when the people were talking about the connected health. There's no AI at that time. AI is not even necessary, is a driving force for the connected health, okay? And then I use this, I remember 10 years ago when Hong Kong invited me to give a keynote at Boston. So this is exactly the same, 10 years ago, the slides, I listed some potential benefits to give you an idea that that's the vision for connected health. So for example, the first one we're talking about is reduce cost. No matter what you are doing here, if you are not be able to reduce the cost, the hospital will not buy in. So keep that in mind. If you are propose a new technology, reduce the cost is number one priority. If you cannot reduce the cost, people normally, if you want to talk to the CEO of some hospitals, they will be very hesitant to talking to you. So for example, reduce the physical check. So I still remember I use example in choosing city of Shenzhen. It's one of the big city in China. It has a 10,000 population. If you think about it, give this 10,000 people annual check. If you're using all these facilities available in Shenzhen or in that city today, it's taking 3.5 years. If everybody getting one physical check, 3.5 years. So that's not going to work, right? So most of the hospital need to be used to treat the patient. It's not really just do the annual check. So annual check will be a very cool application for the connected health. right? So so I want to throw this to you. That if you come out with a good solution, can solve this annual check problem, you already help probably 50% of the population on this planet. But as of today, it's not there yet. So that's just the first one. We haven't reached that point. So this picture was coming from one of the hospitals from India. That's China is very similar. If you go to a children's hospital, it will be like this. Even Beijing today is still the same. That's the first one. The second is we're talking about you can improve the efficiency, right? So you can reduce the visit to the hospitals. For example, after you have a surgery, you go home. Then during the recovery period, you can use connected health, collecting those signals. So then the doctor at the hospital can look at you in real time and then say, okay, you are fine. You don't need to come to the hospital. This is going to reduce, right? Reduce the visit. This is very important for either for the young kids, for pregnant, for women, and also for the senior people. For them to moving around is a huge challenge. But today, this problem is almost still there. It's not really solved. So the reason I want to share this with you is our the idea for connected health is trying to do this. But now if you see the shifting, it's going to, okay, everybody goes to AI using data and this, but asking yourself, what you are doing, are they really solving these problems? If you are not solving this problem, you probably the impact is not necessarily there. The third one is, I think, is to make the biggest progress right now is called a personalized treatment. Personalized treatment means you're getting more data about the individual, and then you can do a little bit more precision kind of help. I think with the data, this one, the third one we consider is actually make a good progress. And then chronic illness management, the similar idea is you can reduce this rehospitalization for the existing. So I don't know how many of you are aware of how the insurance company charge monies. So here, how the hospital charge insurance companies. For example, if I need to go to a surgery, I will take a surgery in a hospital, and then after the surgery I will go home, right? Within 2 weeks, if I need to be hospitalized, and then the second visit, the insurance, we're not gonna pay the hospital money. So for the hospital, there's a huge motivation is we need to make sure this patient don't come back in 2 weeks. Because within 2 weeks, come back, they think you're not doing a good job. So you do something wrong. So that's why this patient come back. So because of that, hospitals have a huge motivation, make sure that you are doing well at home or at the nursing facilities. So this is another way perfectly for connected health. So you can kind of monitoring them and etc. But then there's a lot of challenges. For example, you ask the people taking medicine. NIH actually have a lot of money put in here is how do you enforce the patient taking these pills on time and the right pill? Even this is a big challenge. For those of you who are working on this, if you're doing computer vision, and how can you enforce the patient taking a certain number of pills per day? This actually is very important because many patients, the reason they have to go back to hospitals is because they don't follow the rules. And then that's create another problem. So this is a very interesting challenge, but I didn't see in the Connected Health, in this conference in the last few years, I would say many students choosing an easy task to do. This I consider a very hard task, but people don't work on that. That's the last one, obviously, is living better. But this, as I told you, that it's not necessary that kind of, if there's no, I'm going to share you a story later about the latest. So this is, living better is always good, but people getting tired of just monitoring their behavior, and we need to come out a good solution. I will have an example to show you later. And then, for those of you, some of you probably have your academic trees coming here. I want to share with you at that time, after my sabbatical, in 2009, I started thinking about this. Something gonna happen here to do this connected health. And then if you're looking for the whole United States at that time, the landscape is the following. Basically, those are the three major universities. I consider them, UCLA, there is a big group. Some of you probably know that they are actively working Professor Majid have this Connected Health initiative at the UCLA. And then University of Virginia, Guangzhou's advisor, Jack, was starting a wireless health. And then there's a couple of other people. I think John Nash just became the interim provost of George Washington University. So he was also one of the earlier people working at the UVA on the wireless health. And then at the UPenn, Insu Li is leading a big precise center. Basically, if you're looking for this related connected health, okay, I'm not talking about generic health domain. That's it. And then we decided, at the Wayne State, we want to starting a wireless health initiative. Pretty much, almost, we are 1 year behind them, but the sort of idea is similar. At that time, it's driven by sensing availability and also the communication, not related to AI. So here is a figure I wrote in an internal proposal, asked Wayne State to give me $1 million to starting this initiative. This is exactly the same figure I put in the proposal. We even designed a logo here. You can see that. So basically, it's the people getting all this type of sensors, and then you can using, at that time, edge computing is not there, okay? So we just say you can use a smartphone or home server, connecting this, sending to some data center, and then using the data to do some processing. So I just want to, we allocated the four kind of, the research thrust. I remember Ping is not here today, right? Okay. So when Ping was a PhD student at the Wayne State, so his advisor actually, Chandan Reddy, is working on Chandan right now. He's at the Virginia Tech, but Chandan was working on this health. Here, T3, it was leading by Chandan. So I was his mentor at that time. So this is basically the vision we had at that time. So that's just give you an idea about, you can think about, even today, probably people still doing the similar things here, but that was the sort of the vision we talk about. For example, one of the big projects that we have been working on is on how do you do the remote surgery, that when the robotics is working in the ER, in the room, and then, some of the people even, in the golf court, and then how can you do this type of work? But even today, this one have not really been deployed yet. That just give you an idea about where this connected health originally, coming from. So with that, and then we started thinking about, after we working on this for a while, and then when I was at 2013 and 15 was at NSF, and with Wendy, I was part of the program director on the Smart Connected Health. So we decided that we do need have a conference dedicated to the connected health. So this was the logo. Even this logo I was designed by myself. So that was the CHASE logo. As you can see, the focus on connected health, and then you see on the post outside is applications, system and engineering technology. So that was the idea, and this was like a little bit of heart rate, just created this way. The goal at that time is because we realized a lot of faculty members, when they come to NSF visit us, they said, I want to work on the health, but there's no good, conference for us to publish. So many of these health-related conferences, what happens is they are very short. For example, 5 pages. So if you publish a 5-pager in computer science, by the time when you go to promotion tenure, you're probably going to be challenged by your peers because they don't even consider this is a full paper. So that was actually a very interesting observation we have been doing. So the set up this conference, the goal is, we have 2 goals. The one is really trying to create a top CS-focused conference. I'm very happy to see that 10 years right now, we have attracted a lot of senior folks. For example, Dr. Lowe, she is very big in the security, but she's coming here for the security to publish it here. I was very excited to see this, attracting more and more the other areas coming to this conference from BME, right? And that was the first one. The second is really fostering an interdisciplinary, community. So that because if you want to work on the technology side without knowing the real challenge in the clinical side, you are not really helping solve the problem. So our idea is really to have some kind of this conference can bring the people from different domains come here to working together. So that was, and also, for example, Sarah was working on this wearable sensors and etc. So those, we have people from mechanic, we have people from computer science, people from bioinformatics, biomedical engineering. Last year's keynote was from one of my colleagues is leading a big engineering-driven health. So this is the goal here. We are trying to, really build the community. I hope that when you go to see some friends or some of your colleagues, encourage them, we need to bring more awareness, to this conference. It's the same year, that's if you see this, I need to mention that the first year, the first keynote actually was done by, we just chatted in the morning by Professor Jim Cruz. So he was the assistant director of SAIS. So when he's my boss's boss. So when I talk to him, we want to launch this. He's so excited. Like, yes, we need this conference. That's why Jim come here to give the first keynote of the first year. That was him. At the same time, working with a couple of other colleagues, this was the first journal dedicated to the smart connected health. At that time, working with, Elsevier approaching me, said, okay, we want to launch something. Are you interested to be the inaugural EIC? So actually, I have been the EIC for 10 years now. So that many of you probably is serving on the editorial board. Smart Health right now is also the same year launched. That's why if you're the author here, you might see that why there's a very strange, but it's a very interesting arrangement for this conference. Why? Because as I mentioned to you that earlier, we need people publishing in the top conferences, but depending on your university, some universities, when they go to promotion tenure, their department, for example, BME, they don't consider conference as a good publication. So that's why we decided to say, if your paper accepted, as an author, you have a choice to choosing publish on the smart health as a special issue immediately. So actually, since we started implementing this mechanism, 85% of authors actually choosing to publish on the journal directly. And then only 15% of the people choosing to publish at the IEEE ACM digital library. That's the point. The point is, if you want to, you do a work, you need to publish in the right place to make an impact. Because imagine who is doing health, reading a paper in the IEEE digital library. They're going to choosing to reading smart health or maybe ACM health in this type of journals. So that's why in 10 years, this year we will be first time pass 800 submissions. So probably will be, I checked it yesterday night. So we're almost a half a year, already 410 paper submissions at this point. So that's why I keep adding more and more editorial board, because we need to handle these papers. Globally, a lot of people starting publish here. That's again, it's just to give you an idea that the journey here is starting a conference, starting a journal at the same year. That was the time. Now I want to share with you some of the lessons I learned, through this. Now, if you are working on sensors, so I want to share you. Myself also have one PhD student graduated this. So first we thought, fall detection is so important because a lot of people, many of the people, senior people, because of the fall and didn't treat it on time and then passed away. And then if you are the technology people, what are you going to do? Most likely, I'm going to design a sensor so that the people can wear. So we do. If you check out, there are so many papers published in this area. But after we reach to a certain point, after we talking to many, real patients, I decided that all of these sensor idea are wrong. Why? Because people, when they fall, they are in the bathroom. Now imagine if you are in the bathroom, we ask you wear a sensor, where are you going to wear the sensor? So sensor never gonna work because that you said, okay, fine, I put a camera here. Do you want a camera look at you when you do the shower? No, you don't. So actually, this is a typical example is you're now thinking back, all this sensor-based technology, maybe it's okay when you're working on the street, it might be help. But again, you need to know that many of the people fall in the bathroom. So how do we solve this problem? Even today, there's no good solution. Now think about this. If you come out with a good solution, this will be revolutionary because there is a lot of people 4, including my mother, after this, have to go to replace the whole hip. It's just crazy, but imagine this was like in the bathroom, what technology you can use to here. That was on the sensing technology, okay? Now, second, if you are working on system or networking infrastructure, you might think, collecting data, this is easy. For you to publish a paper, you can do very ad hoc way. You're talking to a professor or talking to a doctor, said, I want to collect data, I'm writing a paper. Because your goal is just writing a paper. You are not trying to really solve the problem. When you're trying to really solve the problem, you will find that today, if you want to talking to all these different entities to getting this data to become a real usage, there's a huge obstacles along the lines. So where are you going to get this data? And the real challenge here is you need to make sure this is streamlined, automatically can make sure this happen. But this today is still a challenge because there's no standard here. So many of the papers published today is ad hoc. You just, I know a doctor, I'm lucky, I can write a paper, that's it. You prove that your technology might work, but it's not necessary, it's really, let me ask it this way, is your technology scalable? Can you easily apply it in this hospital, now go to the next hospital? Can your technology be immediately deployed? If it's not, then basically nobody's going to use your technology. That's the challenge. Maybe you can start a company to do that. Okay, that might be a good way. The third one is the data to knowledge. So at that time, 15 years ago, or maybe 10 years, people always talking about data to knowledge. I remember Falam Jahani right now is the president of CMU. He was a former AD at the NSF. So at that time, people's knowledge is, okay, we need to come from this data generated knowledge. But now if you're looking back, knowledge is useful, but it's not very helpful. What you really need is action. For example, Fitbit. Fitbit, when I first introduced, is so hot. Everybody, including myself, buy a Fitbit. Today, did you see, I don't even wear anything. Because yesterday, one of the friends asked me, because I do 10,000 steps each day. Earlier days, I still have some sensors to check. Today, I don't need it, because I know that I need to work in 1 hour, okay? 1 hour is about 10,000 steps. Those Fitbit didn't give me any action. So why do I want to wear this? For me, it's just a burden. It's not useful. And if you're talking to this senior, many of them, they probably don't like that either. It's because there's no action here. If you're collecting data, monitor them, you need to tell them a meaningful action. If there's no meaningful action, people will get tired of these devices. And then I have a lot of this type of devices, just throw it in the corner somewhere. It's because they didn't give me any very helpful information there. And then health applications. Health application is another very interesting thing is I learned a lesson. So I remember when I was trying to write a proposal using this connected health for the cardiology. So when I go to the doctor, at that time, imagine, you are 15 years younger. I talked to them, the doctor said, okay, I can set a meeting with you, and here is our conversation. So a lesson, I said, he asked me, so what do you want? And I said, look, we come out of this technology. We can help this, even help you diagnostic of these diseases. And then he looked at me. So you basically say, you're going to replace us, right? And I was like, yeah, eventually going to be like that. So I said, bye. You can go now. So the way you're talking to your collaborator, we are here is connected health is to help them. You have to be really careful by the tone you're talking to these people. If anybody come here and tell you, my AI gonna replace all of your jobs, so what's your first reaction? You will be very defensive here, right? You don't want to collaborate with these people. So that was another very interesting thing is because of the no trust from the doctors, that's why in the last almost a decade, you haven't really seen this kind of wide deployment. Doctors is not there yet. So we need to bring more doctors here, educate them, or maybe in other ways, so build the trust each other, and then maybe some of your technologies can be applied. So I want to show you an example, which was earlier days. We funded by Katz Foundation. At the Katz Foundation, idea is very simple, because we want to do something is how to monitoring the vaccine in these lower income countries, particularly in Africa. So you might think that, is this a problem? Because you immediately think about the US. And since I come from China, think about China. This is so easy, right? Because every kid, you come here, there is a book, you know that which vaccine you have taken. You thought this is a very easy task. But actually, when we, my collaborator from WHO told me that in Africa, many places, when the kids come in here, they don't even have a clothes. They don't have a name. Now, their name may be just, 1, 2, like this. So how do you really track those kids? What kind of vaccines they have taken? And what do they need to do? Because this is, if you know this, and then they can ship this vaccine to there, and then they can start and give them the vaccine. So the whole vaccine management each year costs a lot of money. How do they do this? So that was the idea. We come out, that's interesting. So the challenge is, how do you know this kid is this kid? I know it's kind of, but you probably got what I said, right? So somebody come here naked in front of you. How do you know this kid, has taken a vaccine before or not? They don't even have a name. So that was a challenge we are trying to do. So we come out this, we call the My Palm van. Today when you go to a Whole Food, you probably see people can use a van to authenticate you now. So we actually have this idea is in 2012 that basically we found out that the palm van, even a little baby, like 3 months, there's many of the existing technology. You might challenge, this technology is already there. You're right, it's true. But in the real deployment is, we actually have I want to show you a data here is, many of this palm van technology at that time working perfectly for the adults, but none of them actually working for the baby. Imagine you have a 3 months little baby to do this is kind of challenging because and also they're growing, right? You're not the same size. So maybe 2-year-old, their hands actually palm getting bigger. So it's kind of an interesting thing. I don't want to go to detail, but just to show you that some challenges you probably, unless you do it, you realize this is a challenge. Otherwise, you might feel like, there's nothing here, but it is a big challenge because the population you need to deal with is from 0 to 2-year-old. And they are keeping, you might ask, fingerprint. Kids, baby at this time, there's no fingerprint. It doesn't exist. So there's a lot of interesting things that we consider this as connected health because you need to, when the baby comes here, you put it a palm on, and then we can take, you need to take this vaccine, and then, they will be doing some stuff. So that was the first thing about this related to the sensing. I also want to share you the other thing. I talk about, the infrastructure-wise. How can you really process this data into this distributed way? This is going to, this was a work. You're going to see this soon. So we call this, for the data processing, data infrastructure, 1.0 is from 2005, where cloud computing just started, to the 2015. This 10 years, as the earliest stage of the cloud computing, basically the idea is you collecting all this data, sending to the cloud, and then you do the processing there. And then one of the classical work is by Jeff Dean, is from Google, is a MapReduce, because you need to write in the code on this, right? How do you going to process this data? So this data was here. Jeff Dean right now is a very, very big name in the AI stage, but the earlier days, this actually is his classical work. It became an NNE member. So that was in the cloud computing, but the challenge is you're moving all this data there. In the health domain, it's very different because the health domain, what happens is people have a privacy concern. There's nobody allow you, even the same health system, the different hospitals, they don't want this data to be moving out of the physical boundary. So that's good to, we call it digital infrastructure 2.0. That is where when we introduce this edge computing comes in. So where many of the data eventually is actually getting much bigger, but they are into, we just choosing 3V, but some of you probably see 5 Vs and different Vs. But the idea is a lot of data is generating at the edge of the network. So now, how are you going to do this? So you have to do the processing from the edge. For example, if you want to write a machine learning kind of algorithm running for across all the health the hospital, different servers. You have to distribute the machine learning. You can't just have one model running there because the data have to be staying there. So that was the idea in the edge computing paper. Antonina just mentioned that we published in 2016. I actually draw this picture there. It's exactly for the connected health. So that was like you have to have a hospital, insurance, logistic pharmacy. This one all connected. And then you can run some interesting stuff on top of it to make a decision. And then it can help you to reach the goal of the connected health. So that was the some earlier days of the idea that you need this infrastructure to support this connected health. So that was the we introduced the so-called edge computing paradigm. This was in 2016 paper, but today I think many of you already got it. Coincidentally, that 2016 I also launched another conference. SEC, Symposium on Edge Computing. This year is also the 10th year. We'll be in Washington, D.C. That the edge computing model today is pretty much, many of you, if the people working in system, probably putting edge computing as one of your research areas today. But similarly, health is just a portion of this. You can also do probably related to the smart home. I consider these two probably related. And then you can do many things. When we draw this kind of, this is today, it's the platform. So you probably not working exactly in this area, but you need to know that this is the platform where you're going to deploy your algorithm. So you have to think about it this way. Then it might be easier that where you doing this. So I heard Wenjin's talk at the UD a few months ago. For example, when you want to run in a parameter server, hey, that parameter server probably could be one over here, right? So you can see that this is the infrastructure. Basically, it's what are you gonna have, and then you can think about where do you deploy these things. When you really come out with these algorithms. Okay, so just to share with you a few lessons, and then I still have a few minutes. I can talk about what I have. We think about what's the next thing. What's the next thing? Just take it easy, okay? You probably disagree with me, which is fine, but you probably already see that I'm kind of really thinking about something, not necessarily along the lines. So I think we should all move on from AI now. So I want to tell you one thing is, a couple of months ago when I was at the DC for CCC, a Future Computing Future Symposium, one of the panelists there through a sentence which is really scary. I know Yi and both of them issue was there. So that they say that why your computer science people feel like AI is yours. You might be laughing. You said, what? AI was invented by the computer scientists. It is true. So similarly, if I ask you, do you think a mathematics department owns differential, integral, all this type of things? It's not necessary because AI today is become a regular tool. Anybody on the street can use it. It's not a computer science anymore. So as a computer scientist, if you are the computer scientist, you really need to think about that AI is not mine. How can I contribute for the future of computing? This is a very big, kind of mindset change. If you are still thinking AI is computer science, is our stuff, so you're probably going to be, lag behind, okay? That's one thing I want to, before I talk about these opportunities. So, some of you probably know what I'm doing in the last 8 years. So basically is autonomous driving era is coming. So what does this really mean to us? You might first think, because all of us probably know how to drive. So you're being embedded to as a driver's way. You need to take your driver's head away. You need to think about as a research, what does this mean to you, okay? So, show you a couple of examples. Looking at this picture, this was 100 years ago from Detroit, Ford Model T to today. This is one of the cars that we have. So the big difference from here to here is the human is gone, right? You don't need a driver anymore. That's the first thing. But does that mean is today the cars can go anywhere? Remember earlier I mentioned connected health. Why you can't go to somewhere is because you have to have a human to drive a car there to do this kind of things. But today, if this For example, if a disaster is coming, you can just send in an autonomous vehicle, go there, and then starting to rescue, to the health, to all kinds of things. You don't need to even need to have people there anymore. That was the first thing. Now the second thing is, that's for outdoor. Now let's look at the indoors. You know that in the United States, I think globally is the biggest challenge. When you go to a hospital, you're waiting there is because of shortage of nursing can push you. It's these people, not this patient, it's these people. So how you can reduce, many of the hospitals is because that shortage of the nursing to moving the people around. You're basically sitting there and then waiting for 3 or 4 hours. So how you can going to do that? So this is one of the wheelchair. It's a smart autonomous wheelchair moving around either at the home or in the hospital. So this will be changing significantly, and it's going to be help. So I recently, when we showing this idea, and then the two CEOs of the biggest healthcare system in Delaware wanted to set a meeting with me immediately. You can feel their enthusiasm, right? So if you are doing research, how do you evaluate the impact? If somebody is eager to talk to you, that means you probably is making some things. So many of the people thinking that what they can do here is they can save the cost, improve the safety, efficiency, and the productivity. And this you can ask ChatGPT, they're going to tell you. But what I want to mention here is something even more bigger than this. The bigger is, assume this is coming. Then what's next? Next is the connected health 2.0 is coming here is because all these vehicles, or either wheelchair or this, they're coming with a lot of sensors. Those sensors originally were not for this purpose. The sensors was used for driving purpose, right? Imagine that one autonomous vehicle, for example, you saw the news that in Los Angeles a couple of weeks ago, 4 Waymo vehicle was being burned. Each vehicle cost $250,000. The reason for that is not because of vehicle. Vehicle is only 10% of that cost. It's really all these sensors. So you all of a sudden getting a device with all kinds of sensors available for you. Imagine that. That will be generate a huge amount of things for you to can do something. And also because the people is studying, they're not driving, then they can do a lot of things, sitting on the vehicle side. Within the vehicle, they call it in-cabin, right? So this is the vision. We're talking about future vehicle in this century is not just a vehicle anymore. It is a mobile computing platform. They can be used to do many things. For example, you can do computation because the vehicle already have a lot of computing power there. You can do a communication because the vehicle can be easily set up a 5G portable stuff, and then you can in a rescue area, in a rural area, in many places you can drive an autonomous vehicle, just drive there, set up an edge server, set up the wireless communication. Then you can start to do all the physical check in the connected health to helping this kind of things. Before it's very difficult because you have to send people to drive in there. And then even they can provide the energy. I know you are not working in this area, but I want to share with you, give you a number, you will be realized. One Tesla vehicle, 75 kilowatts, can be used to power 10 households for a day. One vehicle. So imagine you can just drive that vehicle there, connect it to the infrastructure, and then the whole 10 households can have a power there. This is also a very big deal. And then you can do sensing, even you can do some storage. For example, this poor rural areas, they need to watching some stuff, you can send in the content there as well. So that was the kind of idea. I have a photo here is, just now I said if you want to contribute your vehicle storage electricity to the grid, interesting thing here is, just a little bragging here is, this technology was invented by my colleague at the UD. He holds this, Professor Captain holds this V2G patent in the earlier 1990s. So recently there's a Nasdaq-listed company starting a research lab on our campus is because of his work. So how do they design stuff you can plug in and then your electricity can contribute to the system. Okay, so what does this mean to us? That means now you might be thinking, some of you already think, oh yeah, I should ask my student, or maybe if you're a student, you think, I should think about doing some stuff along this line. Now, immediate question to you is, how can you read the data on the vehicle, right? So this is what we have been doing a little bit of work in this area is, We're calling this as a new vehicle computing paradigm. If you're looking for the traditional vehicle, it's like this. You have sensors, you have a data, and then you control the hardware. Basically, it's a closed loop. But today, all these future vehicles have an open loop here. You have sensors, you have data. A portion of the data going to come here, and then you have a vehicle programming interface. You can support many third-party applications. For example, the health applications you developed. And then you can do many other things, and some of them going back to do this control, but you need to open this up. So that was the idea that we are talking about, how can you enable, the future innovation in the vehicle. So one of the things which was funded by West Digital is, what is the storage system in the vehicle going to look like, right? So today's the vehicle, there's no such a data storage at all. So you need to supporting driving, supporting all the third-party applications. Privacy is another big concern because your driver behavior needs to be logged in here. So you don't need to go through details. I just share with you that one of this ongoing project is called Autonomous Vehicle Storage System. And then you can do, imagine each autonomous vehicle, each day going to generate 14 terabytes of data. One vehicle. So this is huge for all of these kind of, the vehicle, the companies. And then the next thing we have been developed, taking 4 years for us to work in multiple applications on top of vehicle. Then eventually we abstract a common VPI, we call it, vehicle programming interface. So this one show you that a student writing a code for the parallel parking. This is much better than any human beings. I know. I don't know if you can do a parallel parking. Some of you probably can do it. Writing a parallel parking and see this video perfectly can parking to that only just using 10 lines of code, using our VPI, you can do this. So once you open this up, you can start an innovation on this. It's very nice, and this guy is just a mathematical model here, a line code, then they can do perfectly, parking in the lab. So this is another thing. We will open it up. So if you can say, okay, I want to reading the sensor data or reading one of the colleagues said, okay, I can use a wireless monitoring the heart rate of the people inside. And then you can do that because you can all starting talking to how's the people's health related to when they are moving around, right? Well, when I say this is, for this one, you could potentially apply to the wheelchair. It's not necessary just on the road. So that was the other one. And then we recently just to show off this at DC for one of the events we have been built called Volca. It's a voice-controlled autonomous robot kit. So this is the kit. You can build many things on top of it. So basically, you can talk to this wheelchair now. For example, I want to go to kitchen, and then you will drive into the kitchen. And then you can say, I want to meet Mary. Supposedly, Mary is your friend in a facility. Then this guy knows where Mary is, just to go there. Oh, this I can tell you that once we introduce this, many people want to invest us because they see either they have a family member already on the wheelchair, or there may be some, they found it very useful. This is a platform, and based on this platform, and then you can do many other, potential things. For example, you can put in the pressure sensor if you are doing some hip, replacement, and then you just imagine that all these kind of things, since the computing device is already here. So I want to show you that our prototype, we coined as a SWE, The SWE is a smart autonomous wheelchair. So for example, this is in this room, it's called a mini-egg. It's not a real, okay? This person is a real person. So basically our autonomous, the SWE, here is a prototype, need to moving around to all this. For example, this patient said, I need water, okay, something, they can be moving inside and then trying to, moving. I have a little piece of video here. I run out of time, but almost there. Is this working? Yeah, this is an earlier prototype, SWE 1.0 in our lab. So that's, the wheelchair is just $30. You can buy it on Amazon, but we make it an autonomous wheelchair. The challenge is very different from when you drive it on the road because it's a very compact, inside and you have people students are trying to putting a chair in front of you, and then they realize stop here, and then they will go. So if you are working in this space, you probably know that localization, indoor localization is a huge challenge. Without the infrastructure support, how you can pass through this type of, this is very, very challenging for them to moving around. Okay, so I just, stop here to showing this video, and then, okay, so last thing is, in case if you are interested, this is for indoor part, and then for the outdoor part. So on our campus, this is our sort of a new campus here. We are building this we call the Delaware Star, a living evolving test bed, and then we have these vehicles, and then you can do quite a few things on this. If you are interested to do this, on the vehicle side, you're more than welcome to talk to me. We just recently, with the support from Cisco, just deploy a private 5G cover the whole the campus. So this is where our lab is about the signal. So this could be used for many purposes as a test bed for the autonomous driving, and also can be doing, catalyze the innovation applications. For example, for edge assistant robotic surgery. One of our colleagues at Engineering-Driven Health, they are really doing the surgery there, and then how this edge server can really helping them to make this to a reality. Okay, so I think I will stop here, and then hopefully can take questions. All right.
Thank you so much, Dr. Shi, for absolutely wonderful, inspirational talk.
Thank you.
We're opening the floor to questions now. Please come to the mic, or just raise your hand and I can bring the mic for you.
Okay. Why she's approaching here is, in case if any of the other faculty you are teaching IoT or edge computing, so we just 1 week ago just published this book, the edge computing book. So it could be, all right, go ahead.
Great. Thank you for a nice talk. I have a question regarding to the overall, because I think you talked about you had experiences with the health application in Africa, and during my collaboration with a lot of doctors, they always bring one question about inclusivity, and also how do we deal with the bias from the cultural difference, especially although we're trying to, for human subject studies, right, we're usually trying to say, okay, trying to recruit very diverse subjects, trying to our best to balance the demographic distribution a little bit, by recruiting it in the US, but do you have any suggestions for vision? How can we do better to handle this bias and inclusivity?
Okay, so you hear her question. I don't need to repeat that. So basically, now when I know in the AI era, when people asking the bias, mostly because the data set you collecting, for example, my former dean was he's African American. He always challenged us, you guys doing work, because many of the data not come from with them, right? So I think the only way you can do is working, if you need some, this type of, if that is what you are talking about, for the data, the input, then working with the hospitals that they can provide this type of data, then probably at least you can, that might help. And then if you are talking about the different needs, for example, in the developing countries, in developed countries, and then in this real, rural area, even in the U.S., I think there is a quite agencies also focus on even autonomous driving. They're also looking for in the rural area, in a tribe. Last time we wrote a proposal working with some tribes, because they have a very rural area. Even in the U.S., you just need to build in more, collaboration. We're keeping that in mind. Yeah.
Follow-up question is: do you think domain knowledge help? For example, if we collaborate with more art and science people who studying this culture, do you think that will be helpful?
That's absolutely helpful. I'm also on the CCC council. We recently write an article. I can share that with you later. That specifically argue that, for example, for we call the vulnerable population. So many of the technology designed today when we design this, we only consider the we call it, normal population, but the vulnerable population, not necessarily on the wheelchair, could be like for some lower income community, and then for some people with some disadvantages, right? In this case, you need to take their input as early as possible. It's not like I develop a technology and then I give it to you. Okay, now there's some problem. Okay, let me fix it and tweak it a little bit. That's not gonna. We just wrote a quad paper to try to encourage the government to invest more on this to cover this vulnerable populations. That is going to be very, very helpful. Yeah.
Thank you.
Yeah, sure.
Great talk, Weisong.
Thank you.
Thanks a lot. I think there's something I also want to share on the lessons part regarding the connected health. There's also some thinking and observation I have, and I want to get your perspective on that. So the sharing part, actually we started to work on some of the technologies you mentioned, especially the data collection infrastructure part. The earliest work actually goes back 9 years. And there were 2 big projects, and we have been working on, and finally, we have this 3-tier infrastructure, like you said, the sensors, the edge, and cloud backend. And right now, we actually have a so-called home of the future facility. It's a real 1-bedroom apartment with 16 radio sensors. There could be more. There's also Kinect for capturing ground truth for video and depth, and everything goes to the cloud. And it's actually a huge amount of data because we store the baseband signal. So the 16 sensors, if you stream 24/7 in 3 weeks' time, they're going to fill up 20 terabytes of data. So I talked to a few people, including some program managers at NSF and also AWS, higher education. They want to use their cloud resources to help with education. Essentially, it's a huge problem that I think somehow we as the community together need to solve one way or the other. But I was very glad when I saw you said this data collection has been ad hoc in the past. Just a little bit of advertisements here. We actually have built the infrastructure, and we also tried with some other universities. We sent a few sensors to them. The student can set up everything in a couple of days' time because all the software we have provided for a sensor part for the edge server, and it can be controlled and managed from a cloud backend. So we take out all the major heavy lifting for you. And we are looking for people that want to use this infrastructure, and we will do the cloud backend hosting and everything for you. So if you're interested, let me know. We can talk, and we'll be happy to customize our infrastructure and the software for you. So that's the infrastructure part. The other thing, which is my observation, I want to hear your perspective on that. I think right now there are a lot of papers on connected health and sensing, especially since using radio-based sensing as compared to just wearable devices or vision-based because of privacy concern. I think a lot of times people tend to focus more on the algorithm side because that's the part you can claim intellectual novelty, right? But my experience after doing all this work is I truly believe this is more a data problem. Just give one example. With the 16 sensors, we have collected about 60 sessions. Each session is about 1 hour. Real person come in the home of the future, doing a bunch of daily activities. So just for the problem of localization, a lot of people would think you have 16 sensors, you do triangulation, right? There has been tons of work of that, tracking a human movement inside home. But turned out the radio signal, multipass reflection, penetration, everything in a real home environment is so much more complicated you're never going to get a clear distance range to the human, the person. Many of the sensors, if you look at the range Doppler or range profile images, it's pretty messy. Okay, it's far from usually the clean kind of picture, this cluster of human body reflection. Everywhere else, there's no signal. Those kind of scenario is actually very rare, a very small fraction. Okay, vast majority, the signal is very messy all over the place. So I've been thinking if we were indeed to solve this problem, the only way is we have tons of data and also in many, many different environments, many different kind of people, they all move differently and so on. So I could be biased, but I think a lot of the algorithms, if you don't have huge amount and rich enough data to test, it's probably only limited to the small lab environment where it's being collected instead of in real life.
Yeah, for the sake of the time, so I think either we can talk offline, but I think a quick answer to that is you could publish some benchmark. If you are willing to share some of the data to the community. I know Movicom or in some conferences they continue to organize some computation. If we can contribute this data to the senses, I think that might be encourage them to use this data to do the computation. Eventually, come out a sort of a setting for how many sensors do you need, which is accurate enough. Right. You can deploy as many as possible, but that's probably also create other cost and also complexity.
True.
Maybe 3 or 4 is enough, but then this could be make it as a common way for all the smart homes. So
that's true.
Yeah,
that's true.
That might be good.
You're exactly right. That's actually one of the problems we're trying to figure out. How
Yeah. Okay. Yeah. Thank you.
Thank you.
Yeah, I think for